In this video for section 9.2, we're going to talk about testing hypotheses for proportions. The basic concepts are the same as when you're testing a hypothesis for a mean. One of the main differences is that we're going to use p instead of mu when we're writing our null and alternative hypotheses. So let's look at example 9.9. A basketball team is considering raising their ticket prices, but the marketing manager does not want to implement the price increase if more than 10% of the season ticket orders would be canceled. A random sample of 100 ticket holders found that 14 would cancel their orders if the price change were implemented. Is it possible to conclude at the 0.05 level of significance that more than 10% of the season ticket orders would be canceled? So my claim here is that more than 10% of the orders would be canceled. So let's turn those into my hypotheses. As usual, I'm going to start with the alternative hypothesis. The alternative hypothesis is that p, the proportion that would be canceled, is greater than 0.10. That means that my null hypothesis would be the opposite of that. P is less than or equal to 0.10. So let's look at my sample data here. We have a random sample of 100 ticket holders. And we found that 14 would cancel their orders. So when we go to mini tab, we're going to have number of events and number of trials. And then also given to us in the problem is our level of significance, 0.05. So let's go to mini tab. We're going to go to stat, basic statistics, and one proportion. Change this to summarize data. So my number of events is going to be the 14. 100 is going to be the number of trials. Number of events is always the smaller number of the two. I need to check the perform hypothesis test box, and my hypothesized proportion is 0.10 for my hypothesis. Then I need to go to options. I can leave the confidence level the same since I'm not doing a confidence interval. My hypothesis here is that p is greater than 0.10. So I need to change this to proportion is greater than hypothesized proportion. And then I always need to change the method when I'm doing a proportion problem to normal approximation. Click OK, and click OK again. And here are my results. So I can scroll down to where it talks about the test, the z-value, which you sometimes will need to put in the homework problems. But what's going to help me answer my question is the p-value. My p-value is 0.091. So I'm going to write that over here. And then what we need to do with the p-value is compare it to the alpha. So the alpha that they're giving me, the level of significance, is 0.05. So what I'm looking for is p less than alpha? No. P is not less than alpha. It's greater than alpha. So what this tells me is that I cannot reject the null hypothesis. I can only reject the null hypothesis if the p-value is less than alpha. Now, if I had an alpha of 0.10, I would be able to reject the null hypothesis in this case because 0.09 is less than 0.1. But since I'm using a significance level of 0.05, it's not enough evidence to say that more than 10% of season ticket holders would be canceled. So if I do not reject the null hypothesis, then that means that I do not have enough evidence. If I do reject the null hypothesis, then that is enough evidence to verify my alternative hypothesis.